Part 5, Wave and Wave Back. First, this is about waves, particles. Then it switches to pulses. Remember, in physics, waves equal particles and particles equal waves. When I mention one, I mean both. Remember, too, this is the quantum world, very small and very, very strange. Waves. Here are some basic ideas about waves in quantum mechanics. Wave-particle duality means that every wave is also a particle. By studying waves instead of particles, I may have uncovered some new concepts. Map of the universe is in every wave. Everything is waves, so wave back. Waves, like particles, must somehow display on the crests, troughs, and nodes of the wave charge, spin, energy, mass, particle or antiparticle, everything. Two-wave universe. The entire universe could be made with waves and their mirror image anti-waves, mostly electrons and positrons. Constructive and destructive interference means that a wave and anti-wave or mirror image wave annihilate each other in destructive interference. But exact duplicate waves double the amplitude of the wave in constructive interference. Particles seem to be subsets of waves and seldom appear at the nodes of the waves. The uncertainty principle is part of any quantum particle with wave-like behavior. The photon wave seems to be a series of points or pulses. What gives waves speed? Shorter wavelength. That means more alternating crests and troughs equals more energy and less space. They go faster. For something to happen, two waves have to collide, attract, repel, and or separate. Photons in pair production can produce a pair of oppositely charged particles. This usually results in an electron-positron pair, a V-shaped trail in which each end of the V spins off in an opposite direction and spirals inward. Quote from Nova. This next part is very speculative. Photons from the Dimp universe seem to power everything in our universe. By first converting to a positive-negative pair of particles. The photon pops up, converts to a positive-negative particle pair that are vehicles for energy that do the work. Then they annihilate back to a photon after energy is delivered. Photons may never leave Dimp. Instead, that pulse of energy converts into a positron-electron pair that travels through space, time, and does the work. So when you see a photon in a reaction, it's really an electron and a positron in a reaction. Picture not a ray of light, but a line of photon pulses that look like stepping stones. At each pulse, the photon converts to an electron and a positron pair. The photon shoots out the pair in opposite directions. There is a positron crest in one direction and an electron trough in the other. Where they meet is both the photon and the node of the wave. This looks like a single complete wavelength, but it really is quantum fireworks with two energy rockets taking off and curving or spinning in opposite directions at every stepping stone. My scenario suggests that each photon wavelength is a composite of three things. A separate photon at the node in the middle that shoots out a negative electron trough on one side and a positive positron crest on the other. Look at particle photos and they show visual examples of this pair production. See each of the two, positron and electron, curve in different directions such that one flies off in clockwise direction and the other in counterclockwise direction. Particles pairs may be why there are only two charges, negative or positive. Then, even more important, when the stepping stone-like photons line up, they alternate positive crests with negative troughs. These interact such that different charges attract and like charges repel. This may be a clue to how waves move with these two possible scenarios. 1. Positive crest pushes a negative trough, pushes a positive crest, pushes a negative trough, and so forth. So, photon waves are energy engines with alternating positive charge crests and negative charge troughs. These alternating charges from crest across the nodes of the wave to trough powers each wave forward like alternating pistons in an engine. Or 2. The photon converts to a series of pulses of electrons and positrons that, at each step, immediately annihilate and turn to energy that powers the wave forward. Direction counts. Photos show that when a photon makes an electron-positron pair, they both fly off in opposite directions, with one spinning clockwise and the other spinning counterclockwise. This looks somewhat like the letter Y or V, with the two top ends in opposite spinning spirals. That suggests that just maybe electrons are a series of spinning pulses all spinning in a clockwise direction, and positrons are a series of spinning pulses all spinning in a counterclockwise direction. Each could go the other way, but whatever it is, it's always opposite. Clearly, electrons and positrons are key fundamental particles. They were mostly made and separated from each other in the Big Bang or Little Tear. Both may be strings of pulses of only one charge. Neither has both alternating crests and troughs of opposite charge like the photon does. Each is missing something. The electron has all negative charge pulses spinning in the same direction. The positron has all positive charge pulses spinning in the other direction. That means that the electron is missing the ingredient from the positron to give it full energy, like photons, and the positron is missing the ingredient from the electron to give it full energy. Photons have alternating charges, electrons have only negative, and positrons only positive. That would suggest that the electron spinning pulses are attracted to the positron spinning pulses to supply the other half of their energy. This is exactly what happens when an electron and positron merge. They annihilate back to photons and pure energy. That would explain what charges. The electrons and positron are each half photons and half energy that miss their other half. That attraction to be completed would draw them together. That attraction is charge. Positive attracts negative. More speculation. When you imagine a spinning electron or positron with its single charge, you clearly see that it would spin into a tighter and tighter ball of energy. Does that concentrated ball of energy play a part in quantum physics? Besides electrons and positrons, there are two other fundamental particles, protons and neutrinos, plus one more building block, neutrons. Proton is a stable hybrid of two positrons and one electron in between. This gives the proton a plus-minus-plus makeup. Add those up to get an overall charge of +1. Far as we know now, protons are so stable they are indivisible and immortal. Neutron is an unstable hybrid of two positrons and two electrons that alternate. This gives the neutron a plus-minus-plus-minus makeup and its overall charge of 0. Or, a neutron is one proton connected to one electron. The neutron lasts about 10 minutes outside of the nucleus and quickly breaks down into beta- decay to a proton, an electron, and an antineutrino. Neutrino. Best guess that this quirky, very, very little thing is an electron or positron, but without charge. With no charge to make it spin, either way it just might shoot out as an almost straight wave, or it's just a bit of weird, unexplained energy. End of part 5.